In our last video, we found the angle between two vectors u and v to be this calculation. Along the way, we derived or came up with this idea of dot product. That the dot product of the two vectors is the calculation u1 times v1 plus u2 times v2 plus u3 times v3, a scalar. And we can use that to find the angle between two vectors. But if I were to look at this statement and just imagine rewriting it, right? I could take the cosine of both sides or rewrite the inverse cosine as a cosine, either way you want to think about it. I'd get this statement. And then by multiplying by the denominator, I would get that u dot v is equal to the magnitude of u times the magnitude of v times the cosine of the angle between them. And this gives me another computation formula for the dot product. You can in fact think of that as an alternate definition, that u dot v is equal to the magnitude of u times the magnitude of v times the cosine of the angle between them. So if I know my two vectors, I can calculate the dot product. Or if I know the magnitudes of my two vectors and the angle between them, I could calculate the dot product. This comes up quite a bit, that we only need to know the magnitude of the two vectors and the cosine of the angle between them to talk about the dot product. Also, it'll let us know that if we ever see this or something like it, we might be able to think dot product, which is a pretty easy calculation if I know the two vectors. So, one more thing to talk about. Let's think about two vectors that are perpendicular to each other. They make a right angle. Right, u and v, and then the angle between them is pi halves. Well, using this formula, u dot v would be this. Whatever the two lengths are, multiplied together times the cosine of pi halves. Well, the cosine of pi halves is 0. So if I have two perpendicular vectors, their dot product is 0. And also, if I get a dot product of 0, then the inverse cosine is going to give me back pi halves, right? Because I get 0 on top and I get 0 back. And that leads us to this definition. If u dot v equals 0, then we say that u and v are orthogonal. And that's a new word here for this case of vectors. And the reason we need a new word here is because there's one tricky vector. If you let u be any vector, and then think about u dot the 0 vector. Well, that's u1 times 0 plus u2 times 0 plus u3 times 0 is 0. And so I get this idea that the 0 vector dot anything is 0, so it kind of behaves like it's perpendicular to u. Well, that's not exactly how I tend to describe it, because there's a vector u and then the 0 vector just hanging out there, not really pointing anywhere, has 0 length and no specific direction. And so the word orthogonal can describe both the perpendicular situation and the situation where I might be dealing with the 0 vector. All right, so there's a little more information about the dot product. When you're looking through your textbook, you're going to see a table called Properties of the Dot Product, and you should pay special attention to that table.